Welcome to Natural Habitat Adventures, Daily Dose of Nature. I'm your host, Sunny Vanderstar. Today's topic is Beyond Birds and Bats, Other Flying Animals. And it will be presented by our fabulous NatHab Expedition Leader, Arpita Dutta. Arpita, thank you once again for presenting to us today. This sounds like a fascinating topic. Let's just go ahead and dive right in.
Thank you. Thank you so much, Sunny, and thank you everyone for tuning in today. It's been always a pleasure, for sure. But before I start, I want to ask all of you that have you heard the song of R. Kelly that I believe I can fly? And I believe I can touch the sky. I think from the when we don't know that we can do paragliding, bungee jumping, and all this, other things to feel that air. But when we are young, seeing the birds, I think most of us must be thinking, wow, it's amazing. I wish I have wings like them to fly. It will be so easier to travel from one place to another. That time it was an imagination, which was a beautiful imagination. But right now, the city traffics, trust me, looking at them, I feel like I wish I had wings, to cross it. But yes, with all this, looking at the birds and the bats and the insects, especially who all have wings to fly, and all these arboreal animals negotiate with a highly three-dimensional world. They have to live in, and which is like depend on many spatial scales. That means that maximums, it can be of the body proportion, the length, the distance, all the physics and maths into it. It's engaged in the spatial distance, which covers a lot of topic in them. And so that has to be a continuous thing for them. Like this all placement of these spatial things has to be there to make an animal or to make it fly. Of course there is. But in case, as the scale of substrate, which means like, imagine in an easy way, like the encoding and decoding of when it becomes in a discontinuous, when it increases, this discontinuity increases, then many arboreal species rely on leaping or gliding for locomotion between a distance support. So they are like if we go back to evolution, they were like something pushed them to involve or to adopt all these extra specialized features in them so that they can either to escape or to catch food or for mating or just traveling a distance at a safer place. They have grown this ability of gliding. So today, whatever animal we are going to cover, it's not only, it's not like the true flight, but they glide even a long distance. And honestly, for all these mechanism because it's aerodynamic, I was just discussing with Sunny that it's all about aerodynamics, air pressure, the thrust and stuff. It's all like big mathematical calculations are there, which is and maths and physics, these two things are really not a very friendly subject for me. So I'll try to simplify the thing with the physiological and the adaptation part of the animals, especially focusing on the animals, that how they do it. Okay, so in order in order to like successfully move through their habitat, these gliding animals must actively modulate two things, which is propulsive and the aerodynamic forces. So they need propulsion to push forward. They have to move forward, right? And for these aerodynamic forces, they have to like take care of this lift, thrust, weight, and drag. This is how we take off, like, of course, the flight or this thing, they take off. And it's not only, it doesn't end there. All these forces has to be balanced. Then only it will be in dynamic equilibrium, you know, where without any harm or without any effects of in their body, they can glide from one distance to another. So here, so the animals are capable of aerial locomotion, these animals, and either by powered flight or by gliding. So imagine here, these are the relative things for the aerodynamic forces. And here, from a distance, see if this is the object over here. If this is the object, see when it is moving down, the body posture is changing, and which really helps them to modulate their speed and and also during the landing. It has to be a safe landing, right? So that's how they do it. Sorry. So this is how it happens. And for all this thing, especially when it comes to the mammals and stuff, especially the gravity, I mean all these animals, gravity plays an important role. Apart from all this thrust or the aerodynamic motion what they have in the air, I mean through the when they're passing through the air, the gravity plays an important role, of course, because that's where they go down. So before that, I will talk about the mammals first, that they have some adaptation, you know, which is the posture and the orientation part, which is more important for them. So the gliding mammal's body is elongated, flattened, and streamlined. And let me tell you, all the gliding animals, they are they all have actually the streamlined body, because that's how they have to cut through the air. I mean, that is how their physical adaptation has happened. But with mammal, they have few extra things, which is sorry. So these limbs, what you see, they are long and equal. The tail, where you see it here, it's flattened at the edge, and then it tapered at the bottom. And with that, they have this loose skin. Few mammals would have this skin, this loose skin attached from the cheek where my cursor is, and few would have it from the neck, and that is in different species. They have, I mean, different genus have different ways of attaching this fold skin, and this fold skin is called patagium, and this works like a parachute. This membrane, this patagium is stretched on either lateral side between the neck, limb, and the tail. So what you can see in the diagram. And their nature of like gliding or the flight. So how it does is, sorry, I'm really sorry, I'm just having a little throat problem. Gliding is not a true continuous flight, of course, but merely a prolonged aerial leap, you know, covering from 100 to sometimes 200 meter. So this type of movement involves no propulsion, because it's all about pushing yourself out from the area and moving to somewhere else. It's like falling. I'll come to it. Other than the initial force of jumping, that's what they need, these mammals need to do. So it is characterized that, you know, by leaping or jumping from the high point and held up by some sustaining organ to glide to the lower level. So there is no locomotive force other than the gravity. I'm telling this again, again, because that you would figure it out, that why is it so important for them. So that's why gliding mammals need to climb. Like if they, first of all these arboreal animals, they mostly live in the trees. But sometimes they need to come down. But when they have to like climb, or they need to glide to reach at other places, they have to climb really high at the top of the branch where there is a gap, or they get a free space. And from there, they take they take that leap, uh, and glide smoothly and swiftly downwards from one tree to another by using little maneuverability. That's a little movement is there to get them into the right place they wanted to land in. The glide can be guided to some degree by changing the position of limbs, the patagium, and the tail swift. Imagine how the aircraft, and it's very well seen in the Air Force plane. So those, if you see, there is a quick shift, and they can actually turn into a different direction. That is how they do it. But in different species, the exact area of the body has to be twist or turn to reach, to make them land into their preferred places. So with this, let me get with the first animal, the mammal. It's the colugo, or the Sunda lemur. They are not close to the lemur, of course. They are not even closely related to lemurs, but these colugos, they are mostly spread out in the Southeast Asia's rainforest. And the only who are closely related to a primate which can glide. Look at this beautiful face. Look at this tiny little one which is hanging with its mother. They are like they prefer to live in the tree plantation areas, and they choose to be on those trees which has less branches on the lower side of the trunk, so that it's easier for them to climb at a height, and from there they can have the better view to jump to jump. Yeah. So they are solitary and vegetarian. They are nocturnal, and you can see the size of their eye. With that, we can figure it out that they have a very good night vision. They start moving, or I would say that they become active during the evening to their feeding areas, and they keep moving from one feeding area to another. And with that, they can glide a distance of near about 135 meters, which is a really big leap at one stretch. And sometimes they move with their young. So how do they do that? You see, it looks more like a bat, but the colugos cannot flap their patagium, there's membranous wings, they cannot flap it. They just make it open. They keep it open to give it like a parachute effect. So the animal must, generate the muscular force to propel their body into the air during the takeoff. They glide smoothly because of the light body weight. Light body weight means they have lighter bones. Not like porous like birds, but their bones are pretty light. And also after they stretch out, like initial accelerate under the force of gravity, which it's going down, then they accumulate the kinetic energy, which must dissipated at landing, and otherwise they would crash. So once it reaches that equilibrium I was talking about, that all four things has to be on the line, the landing force is no longer increase or decrease, and it has And of course, because it stays in the tree and they glide and they hold the tree like this, just like the koalas. So see, they have very strong wrist muscle and they have carved claws like this. See this, and sharp as well. And they hang and hold, which, you know, whenever they are resting or landing, sometimes they hang themselves like a possum as well, but not upside down. They, with the four limbs, they hold it. And with this, the colugos are, you know, even for that side, as the mammal, I mean, be it with the babies or with that, I mean, if they are not crashing, so the landing has to be smooth. So as I said that there is no increase or decrease of speed at that point of time when they reach at the equilibrium, but where they need to land, they first move their front part of the body, which they need to go. So that controls that thrust, and then they slowly push their bottom portion to the tree, and that's how they get into it. But unfortunately, that's a beautiful species to look at. But unfortunately, it's a common theme for a lot of the species which are facing this crisis is the habitat degradation, habitat lost, and then hunting is there for declining of the species. But still, it is least concern according to IUCN status. But of course, if it continues like this, and they need a continuous forest, you know, for their movement, because they don't come down. But hopefully, but if you are traveling to Southeast Asia for any forest, you definitely can visit these areas. In Philippines, you get to see different endemic species out there as well. Okay, with that, we have the flying squirrels, are the superhero of the squirrel world. You know, when we talk about the squirrel, especially the flying squirrel, I think they are excellent at surprise appearance and disappearance. I mean, many times it happens. India, we do have quite a few species, and sometimes we see that it hopped or it jumped from one tree and then it vanished. I mean, no matter how long we are, so they kind of, it's very shy. It's very difficult for us to, you know, find, unless and until you know the roosting area of that particular one. It's difficult to come across the flying squirrels, and there are about 50 known species of flying squirrels spread all around the world, you know, and they mostly stay in the tropical, the subtropical, and the rainforest areas. They need thick forest, and they are omnivores. And the mechanism they follow is same as the colugos. You know, flatten, spreading their patagium membrane like the parachute, and they glide from one area to another. And only one thing, and they cannot fly even long distance. They fly very short distance, which is 90 meter is the highest recorded till date. But they can do another thing, which is they can also turn 180-degree in the mid-air. You know, their limbs and their rubber-like flat tail help them to steer and control their leap. That is there. And they have a padded toe. So whenever they are landing, that absorbs a lot of thrust in that. So of course, they also do a very smooth landing. And one interesting part about this flying squirrel is, you know, the earliest fossil skeleton of flying squirrel, like dated back to 11.6 million years ago, which is very similar to the large flying squirrel that is found in the tropical and subtropical forest of Asia. So imagine how the evolution has happened. See, 11.6 million years, my God. And the first specimen, I mean, the fossil have been found in Spain. which is 40 in Spain, in a city 40 kilometers away outside the city of Can Mata city in Spain. Of course, I don't know about the city, but yeah, from there they have found this fossil of that 11.6 million years ago that has been dated. And they are nocturnal also, and they to escape the predators, and they are omnivores. And you know, this nocturnal thing, but sometimes we got to see flying squirrels in the thick forest, you know, where there's a like canopy. They sometimes remain very quiet, you know, curled up kind of a thing between the branches. We have come across flying squirrels, especially in the northeastern part of India, which shares the Indo-Malayan border part. There we have seen, even in the daylight, we have seen, but yeah, they were not active. It was just there. The tail was hanging, that you can figure it out, and then it was there. But yeah, it's very, very special to see these flying squirrels. And yeah, so because I'm saying very special, because they are we have few critically endangered species, and that is, one is the Kashmir flying squirrel, which is the northern part of India, which is close to where our snow leopard trips happen. And one is another is the Namdafa flying squirrel, which is again little close to Kaziranga, where we do the trip. But of course, that is in a little high elevation. So this is about the two mammals which fly like this. Oh, sorry. This is the skeleton which have been found in Spain of these flying squirrels. Yeah. So the next, and for these flying squirrels, of course, habitat loss is there, which is a common thing, as I mentioned. But in those areas, hunting is also another big threat to these species. Though we have laws that if anybody is found, they would be in jail, or they have to give a huge compensation on that. But still, in those tribal areas, it's so big, and the forest is so huge. It has the highest forest coverage in those areas. So of course, we cannot, though people are getting aware of all these things, it is much less than before, but still it is quite threatening to for the species. Okay, so let's then get back to our flying dragon. We know a lot of dragon stories, and especially I think the Game of Thrones has given a dragon a special picture, though I haven't seen the series yet. But yes, the dragon, a lot of stories on dragon definitely have gone through. But seeing a flying lizard doesn't make it much difference to feel that how the dragon fly or glide in the air, I mean through the air. This is a dragon. This is a Draco. It's called Draco. So this is an endemic species to the southern part of India. We do have few species of Dracos here in India. But yes, so look at this first picture here. It just landed. I couldn't take the flight, but it just landed here. If you look closely, you will see that the spine and these ridges are the ribs. They have elongated ribs which can be extended and retracted while they're flying. And this three-dimensional wing shape, it's the best way where they perform an efficient gliding in the forest, because they also live in the thick tropical and subtropical or the rainforest areas. And you know, these chances of predation, I mean, if I go back to evolution, the chances of predation is more on land rather than in air or at the top canopy. So with evolution, they have developed these features which can help them to survive in such a way. And it's almost like about 1,000 years before the Dracos have left the ground and adopted this capability. And they have, as you can see, they have this elongated ridge. So this is like the triangular sheet of membrane which is attached to the ribs. And if you see the fine lines here, these are these elongated ribs. And this fold of skin is attached between these ribs, which unfurled during the flight. You see it here, though it's not a very good picture, but you can figure it out that how it happens. It's exactly below the limbs this parachute membrane has formed till the hind leg. And this also supported by the hyoid bone, which is present in this lizard, in the Draco. So Draco use their long, slender tail to steer themselves. And the distance they can fly up to, they can glide up to almost 58 to 60 meters. I mean, that is a long distance for just, it would be maximum with the tail, it will be around 8 inches. So that's actually a small one. And, and these males are very territorial. The males are very territorial. You see this, this thing here, they attract and also they display to attract the mate or to get into a fight with another male. So all these things, and they are territorial, that makes us little fortunate, because if you find a Draco in a tree, it will be there at that particular area, and but you have to look for a few, maybe another 5-6 trees to find it, but it will be there unless and until it feels threatened to be there. But they never, I mean, they most of the time they never leaves their territory behind, and they follow the same thing, that they climb up, and then from there they take a leap and they glide. And of course, their flattened wings catch the wing and fix that equilibrium and get into those places. And they are very accurate where they land, because if sometimes they see some insects, and if they see it, they would directly fly in that, and because they can't give time for those insects to, escape. So they are very accurate on that. The next, again, it's a reptile, but the only limbless glider is the paradise flying snake. Not only the paradise flying snake, but all the genus, I mean, most of the snakes in their genus, which is Chrysopelia, they have the ability to glide. And this, and and despite of being limbless, it can successfully launch itself from the tree top. Imagine all these mammals or the Dracos, they do have limbs, so they can push. I mean, the propulsion which is required, that they have to move forward, they have to give a push. But for a snake, it is difficult. So what exactly they do? The snake have rough ridges like scales on the ventral side, that means on the belly. Especially, it is all applicable for all the tree snakes, and which they push against the tree trunk and climb up. And then it dangles. See this? Like this one. Then it dangles from one of the branch and then contract sharply like a spring to launch itself into the air. That's how it gives that force to get into the air. And then the rest, the gravity is definitely work. And with that, the initial angle of the inclination actually determines the gliding path. So I could not put the arrow properly, but imagine the face is on this side. So if we see that this is the area they want to glide, so this here the dimension, or here the central force or the gravity would work, and when they launch, they will exactly make an angle. So if this is the angle where my cursor is, they would move exactly this much from the place where they are hanging. And that is how, when the snake is about to leap or it's leaping, you know that exactly where it can fly. I mean, this is like with practice, you can get this idea. So with that, and it doesn't, and before that it launches, what happens is to ensure the maximum, gliding space, the snakes will suck in its stomach. Like when we take photographs, we try to push our belly in so that the bulgy things doesn't come out, but the snake does it for the flight. So it flattens it flattens its body and curving inward to create a lift and undulating its body to a S shape. Here you see it's the one, and this is the flattened part of the body. And let me tell you, in anatomy, like the snake, all the organs in the snakes are elongated, are shaped like elongated shape. So while it flattens its body like this, this is how it works, and then it takes the stride, with the motion, and with this, the suction plays an important role. When the snake flattens the body, it makes itself more aerodynamic. Of course, when it's when it's in the air, and the snakes could glide almost 24 to 25 meter from the launching branch. So that's how definitely it goes, and it follows the same movement, like it climbs up at the top and then from there it's glide. But it's almost like a ballistic movement. Even in the water, they do the same formation, and for a snake, it does the same formation of this S shape, the curled up H shape, even if when they're passing through the air. Okay, that's so sometimes in Borneo, definitely in Borneo, in the sun bear conservation area, there are few paradise flying snake. So if anytime you are planning to visit, or you have visited, it would be high chance to see them there. It is a good thing to see, because these are the only snake species which have this capability. And with the snake, we have almost the same capability they have with the frog. It's a little one, but I can call it a daredevil one, because in this rainforest areas, it just being so tiny, it can actually jump at a long distance, not only on the ground, but it glides with that. And and it's soar. I mean, if you talk about like the wings, the waved feet is almost acts like a wing for this gliding frog. There are different species of gliding frog, and mostly you will find it in the rainforest area. And they have adopted a little faster travel techniques, and they have if I come to the physical features, see, it's a very streamlined body out here, and then it has adhesive disc toe pad. This is a toe pad, and these are adhesive because where they're gliding, I mean they're holding, or where they're landing, they need to stick out there. And see the webbed feet out here. The skin between the toes is pretty wide, and so that makes them that parachute effect. So here, look at this picture. I mean, this is really funny, but this is how it glides. And you see the posture of here. The hind legs are pretty long and strong, for which it helps them to take that leap. It forcefully pushed it backward, and then they take the leap, and with that they can actually fly like this. And sometimes they land up together into the same area, and mostly that happens when there is a mating season is going on, because when the male calls out, if the female is there, there are multiple males which come there to do the to try to do the amplex. Of course, they create a foam nest for which they lay the egg, they release the egg and sperm, and they go with that external fertilization. And yeah, it's fun to watch them at that time. And so the interesting part about this gliding frog is, of course, there is an evolution, and because of evolution, they have adapted all these specific features. But it is also found that they have huge genetic variations than the non-gliding frog. It has been found that there are near about 455 modified genes in the gliding frog, and most of these modified genes work for their webbed feet, limbs, and toes. Imagine, so I mean, out of this, most of the genes have only processed with evolution to give them a better or stable external features or the physical features to give them a proper way to glide through the air. And of course, this wave feed makes a lot of sense, right? So there is there are a lot of species, as we know that, but there is Wallace frog has the largest webbed feet, which you will find in Malaysia and Borneo. So you can look for it as well. With that, with the same capability, but not so professional or not so finer like the wave, the wave gliding frog. So this is the Cole's parachute gecko. Look at the wave toes out here and the flat tail, and this helps. Over here, if you see the body, they have this loose skin on both the sides, and this is how this just got stuck. But this is how they, when they leap, take the leap, they glide, and of course this gives a parachute effect and stable with maintaining the proper equilibrium so that they can glide from one distance to another. Now the best thing about, we have all talked about these arboreal mammals and reptiles, but it's great to know to learn about them is the marine and the freshwater species. So with the marine, I would talk about the Japanese flying squid. So before we go ahead, I would say that they look at these areas. Okay, these are the tentacle area where the arms, they have the webbed area or the skin where it is attached between their tentacles or arms, and over here they have the soft fin which almost acts like the wing. And when they are not active, these fins and arms are folded, and this is how the squid looks. And let me tell you, these tentacles have the ability to expand and retract, just like the Dracos. So here how it happens. So it actually doesn't need, I mean, the fin or the arms are not the primary tool for the movement. What they do instead is they race through the water via jet propulsion. They take water into the mantle and then forcefully expel the water through a siphon. So here you have, if you see the picture on the right, you will see there the dotted water is there. So that's the jet spray they do. So once they're in the water, they are at a speed of almost like 30 to 30 kilometer, 30 meter, like it goes in the speed, and then this jet spray the jet spray the water, and from there they fly. And when they took off, they actually expand their tentacles or the arms and the membrane, which gives them to hold themselves in the air when they glide. And this and because of this webbed one, they actually maintain a good balance above the water, you know, keeping it stable in the flight. And when they are about to land, they actually close these fins and the arms closely, and it's narrow it down and it gets back into the water. And that's how incredible that they can be there, and they can cover a distance of 30 to 50 meters, you know, in 3 seconds. I mean, imagine it's there. Sometimes it has been noticed more, which way I say it's 50 meters as well. So this is how the squid flies, and this is a picture. This is a real picture. I mean, I was so amazed to see this. And look at this, all the squids. And of course, they do that if for the predatory fish or for the predators, when they come out and all, they move together. And of course, when they are above, they've feel threatened by the birds as well. But of course, when they are together, there's a good chance that they do escape most of the time. But there is an unfortunate thing that though it is least concern in the IUCN status, but it's a popular dish, Japan, South Korea, and North Korea, and it's a costly catch as well, you know. So this is more used as the food and the delicacy of this flying squids. I hope they remain like that. And imagine it's almost 160,000 metric tons has been catched in 2017 and 18 just in 1 year. So you can imagine I mean how much we are forcing them, you know, to sustain or to survive. And because I'm so sorry, because of this climate change, the temperature of the sea is changing, and with that, a lot of species already feel a lot of threat. And of course, all these direct human activated things are also sustaining at the same time. So not very different, but they are the gliders of the ocean. They are the flying fish. There are near about 70 known species of flying fish, and they live in the tropical and the temperate marine areas, which is like Atlantic and Pacific coast of even in US. And it can also be found in Indian Ocean because there are a few records of seeing them, like the flying fish out here. So they are shaped like, you know, torpedo, which has a streamlined body. Again, they have to have that, and let them build up the speed underwater, you know, to break the surface. And they have a reinforced spine, large cumulative fin surface. Look at this. It actually looks like a wing. And then the lower body part allows it to glide. And see this. It has this, but this has so much thing to do with this one. You see this ripple in water? So what happens is the large tail allows them to build up that speed for which they need to approach towards the surface, which is near about 35 meters per hour. They move underwater. And then once they break the surface, this lower part of the tail, which has a forked fin out there, so this lower tail lobe can still beat in the water, you know, providing further thrust to move it forward. And at the right moment, the large wing-like pectoral get extended by two muscles which are working, is the medial and the lateral muscles. I mean, those get stiff. It's like a tension happens there. And then this pectoral fins forms like a wing, which is outside, which push outside. And it gains the lift and become the airborne. And some large some large pelvic fins are also present in different types of flying fish. If you see it here, you can see a little portion of the pelvic fin here, but that also an additional support or to move it more forward. And this fish can actually glide up to 200 meter. And it has been recorded that consecutive dive spacing, it can move up to 400 meter. I would say there is a documentary in BBC called The Hunt. It is like a series. So over there, and this is one of the best series of BBC. I would definitely recommend if you go through all the series of Hunt, and there you will find this fish like with the moving, and you have that how exactly it happens and why they come out. All the mackerel and other big fish they travel in. And you know the basic part is when the birds see that there is a mackerel, pool is there, they actually hover or soar around that area because they know that that's a hunting ground for the mackerel. And then this flying fish comes out of the water and they fly a long distance, and there the birds actually catch them. And if you have seen the life of Pi, and of course, over we have come across a lot of flying fish movement out there as well. So yeah, they are very fascinating and very popular in the ocean world. So with this, the ocean world, that means the marine. Now we have another freshwater fish, which is called the freshwater butterfly fish. And see, it has also have the same pectoral and pelvic fin, which is which is very thin, light, and they can also expand and retract. And they are very accurate. So whenever they see any movement of the insects, whichever they would fall in it, or it is outside the water surface, maybe hanging from a tree leaf, they actually pull their body way up, and they grab that insect, and they most of the time they are 100% accurate, and they are found in the Amazon River. And with this, we have we are talking about so many gliding animals, but imagine almost 160 million years ago in the late Jurassic period, the non-bird dinosaurs used to glide in the same way. They don't flap. They never used to flap. They used to climb high. And because exactly the fossil which has been found in China, it has been found that they have that presence of parachute membrane or the wing type membrane, just like the bats. They do have that membrane. So if we would have been there in that time, we would have seen these dinosaurs are gliding, or they are getting different modes of movement since then. So evolution have taken a long place, but of course it's still a lot more things are there that which nature keeps on throw us rather a lot of questions and keep on mesmerizing us. So yes, after seeing them, I can feel that maybe in another few hundred years, you never know. Maybe some other animals would develop or adapt, or rather human, to get out of the traffic. We develop something to glide. Already we have innovated a lot of things. So yes, innovation triggers, this necessity triggers the innovation for sure. Thank you so much. And I'm so sorry. I don't know why my throat is paining so much, but I'm really sorry, because for that I had to stop quite a few times in between. But I hope you got something out of this webinar. And thank you so much. Sunny, I'm ready to take up questions.
Oh, Arpita, that was a fabulous presentation, so thought-provoking, and we hope you feel better soon. Sorry that you're having trouble with your throat. Um, Before we start the Q&A, I just want to remind everyone they can submit questions via the questions field in the control panel. But we've got a lot ready for you, so I hope you're ready. What does a mother do? I assume this is for the flying squirrels. What does the mother do when the baby they're carrying falls down during flight?
Oh, they don't. It's just like the bat, how they cling to their mother strongly. They most of the time they don't unless and until they lose the grip because the mother cannot hold them, right?
Mm.
Because their forearms and the tails are, stretched for the glide.
Mm-hmm.
But that's how they are used to. I mean, the babies, what I have seen in bats and these flying squirrels, the babies hold, the grip of the babies is very tight. I mean, they
Mm.
hold the mother like a, like a gum.
Yeah,
They are adhesive, like to the mother's belly. So
they are
yeah, they
stuck
most of the
stuck
time they
together.
are. Yeah, thank you for the word.
So
Yeah.
what does a flying snake feed on?
Oh, they feed on birds, even bird egg, big smaller mammals, other like frogs, geckos. Yeah.
Mm. Okay. And how can the gliding frog land safely on such skinny branches? Or do they land on the larger trunks and then climb to the skinny branches?
No, they can land themselves onto those branches and even on the ground where they which is very rough. But they are specialized in that. So actually, very good question. So what happens? Maybe I don't know. I have missed it. So what happens when they are gliding, like those parachute effect, when they're about to land? That adjusting the body proportion or the area, they actually can reduce the force or the speed of that flight. And whenever they are dropping, it could be with the front leg or with the hind leg, and they are so sticky that sometimes they get stick to that. Once if they stick to any of the branches, they can then turn them and they can climb they can climb up on the branch.
Hmm,
They just need to
fascinating.
touch it.
Yeah.
Yeah.
Are, are the flying frogs poisonous like other tree frogs?
No, no, they are not. They are not poisonous.
Okay. Can you tell us the size of the Japanese flying squid?
The Japanese flying squirrel or
Mm-hmm.
squid.
Squid.
Hello.
The flying squid.
The Japanese flying squid is more like 15-20 centimeter. It can grow.
Okay. And are the flying squid threatened or endangered due to consumption by humans?
The flying squirrels.
Squid, the
Yeah.
Japanese flying squid. Hmm. Are they endangered due to consumption?
Oh no, they are not. They are not endangered. That's what I say. They are least concern in IUCN status. It has not been. We still didn't get the like exact population density of it, but definitely this is one of the delicacy. And I mean there are a lot of factors, which can make them decline, because as we don't know, because it's very difficult to know the population of the species, which is like just like 15 centimeter size, right?
Mm-hmm.
And that is in the ocean. But depending on the climate crisis what we are facing, and at the same time the unrealistic amount of animals which are taken out from the ocean can give them the threat of the declining their numbers.
Mm. Okay. And do you know if birds evolved from flying fish?
Sunny, your voice is, there is a call drop.
Can you hear me now?
Yes.
Okay. Did birds evolve from flying fish?
Uh, Actually, no. It has a complete different mechanism from where it is, and because we all have started from a single, I would say, the cell or the species thing, we have some similarity. We means, I would say, we all, the animal kingdom has some similarity, especially with the vertebrates and all, but not the exact evolutionary thing from the fish to the bird. There are so many things in between.
Okay. Well, I just want to echo the comments that came in, being very appreciative of you bringing us such interesting and unusual topics and introducing us to creatures that we have never even dreamed of. So thank you again for going out of your way to bring us a fascinating presentation. I'm going to turn it back to you for closing comments.
Thank you so much. I think this is the best, to keep you. Keep me encouraging, and not only me. I think all of us, all the ears out here, all your comments, your feeling good is a lot of like feel good part about in our life, definitely, and it matters. I'm not exaggerating the part. At least I get very excited to share what I am learning. So that's really been a sweet thing, and thank you so much for all, to all of you, to be here, and have a great weekend. And you too, Sunny. Thank you.
Thank you. And I want to thank everybody who tuned in today. Please join us again next week for our next daily dose of nature. You can check out next week's lineup, including registration links, on our website at nathab.com/webinars. We did record today's presentation, and we will have the replay available on our website soon. With that, we'll conclude the webinar. Have a wonderful weekend, everyone.